So in the last video, we learned all about atoms. Now in this video, we're going to learn about three other types of particles, which are isotopes, ions, and molecules. All right, and if we can understand these, then we're going to be having a great time, especially next year. All right, so let's start with isotopes. Every element, and you remember that an element is anything that's made up of one type of atom, every element has its own name and chemical symbol. So that's why this is the periodic table of the elements. Okay, so each element has got its own name: boron B and symbol, carbon C, nitrogen N, phosphorus P, silicon Si. Okay, the number of protons in an atom determines which element it is. Very, very important. The number of protons determines which element it is. Every gold atom has 79 protons. If an atom has a number of protons which is not 79, it cannot be a gold atom. Okay, so it's really important that you understand that the number of protons determines the identity of the element. All right, so what I can do is I can say to you, now this number here, the number above the element symbol, is the number of protons. So if I say to you, which element has got 24 protons? Chromium. All right, none of these have got 24 protons. Only chromium has 24 protons. If I say, which element has got 5 protons? Boron. Only boron has got 5 protons. If I say, how many protons does magnesium have? You find magnesium, here it is, and it's got 12 protons. All right, so the number of protons is the same as, the number of protons tells you which atom it is. Every gold atom also has 118 neutrons. However, this is not the case for all elements. So you'll remember in the last video, we had gold has got 79 protons, 118 neutrons, and 79 electrons. Now what I'm saying is that every gold atom has got 79 protons. Every sodium atom has got 11 protons. All right, that number can't change. But this number, the number of neutrons, can change. All right, I'm going to use an example, which is chlorine. So every chlorine atom has 17 protons. It has to have 17 protons. Here it is, chlorine 17. However, there are two types of chlorine atom. Chlorine atoms with 18 neutrons and chlorine atoms with 20 neutrons. So I can have, this is one type of chlorine atom, and this is my other type of chlorine atom. Okay, obviously they look almost identical. And in my nucleus here, in this one, I have got 17 protons and 18 neutrons. And I've got 17 electrons. Now in this version, I've still got 17 protons and I've still got 17 electrons. However, in this atom of chlorine, I've got 20 neutrons. So, because they've both got 17 protons, they're both atoms of chlorine. Remember, the number of protons tells you which atom it is, which element it is. And if it's 17, it must be chlorine. So this one here, this is chlorine with 18 neutrons, and this one here is chlorine with 20 neutrons. Okay, and we do actually give them slightly different names. So this one we can refer to as chlorine because it is chlorine, but we call it chlorine 35. And this one over here is chlorine. Remember, it's the same atom. Yeah, it's still chlorine, but we call this one chlorine 37. And can you tell me where those numbers come from? So they come from the sum of these two numbers. So if you add the number of protons to the number of neutrons, you get this number here. So 17 plus 18 is 35, 17 plus 20 is 37. Okay, so these are known as isotopes of chlorine. Isotopes are atoms of the same element that have different numbers of neutrons. You see they're the same element, but they've got different numbers of neutrons. Because they are atoms of the same element, it follows that they must have the same number of protons and electrons, as you can see here. Okay, now that's quite a difficult thing to understand, all right? Isotopes isn't easy. It's one of the first really difficult bits of chemistry that we come across. And so if you want to stop there and go back and watch that again, that might help you have some more understanding. But there will be some questions on isotopes in the questions for homework. Next, number 2, ions. Okay, all atoms are neutral. They have an equal number of positively charged protons and negatively charged electrons. An ion is formed when an atom gains or loses electrons. So if you remember, let's go back to our example of sodium. Okay, sodium has 11 protons and 11 electrons. What is the charge on a proton? Well, the charge on a proton is +1. So all these 11 protons are 11 times +1. And what's the charge on an electron? Charge on an electron is -1. So all of these electrons are 11 times -1. Right? And the neutrons, well, the charge on a neutron is 12 times 0. Okay, so if I have 11 +1 protons, 11 -1 electrons, and 12 0 neutrons, what's the overall charge going to be? Well, if I add these three together, that's -11 plus 0 plus 11, which comes to 0. So we can say that all atoms are neutral because they have an equal number of positively charged protons and negatively charged electrons. But I can make an ion when I gain or lose electrons. So if an atom gains an electron, it will form a -1 ion. So if I go back to my sodium atom, all right, I'll draw it again here. Remember, I had in my nucleus, I had 11 protons, 12 neutrons, and in my electrons, I had 11 electrons. Now let's say I've now got 12 electrons. Okay, what this means is that I can say I've now got 12 times 0 because the neutrons are 0. I've got 11 times +1 for my protons, but now my electrons are going to be 12 times -1. All right, and if I add those all up, okay, so this is going to give me, this is going to be -12, this is going to be +11, and this is going to be 0. If I add those up, I get -1. So you can see that by increasing the number of electrons by 1, I now get a total charge of -1. All right, and by the same logic, by adding more electrons, I get a larger negative charge. However, if I take electrons away, the opposite will happen. So if I take an electron away, I'll start making positive ions because I'll have fewer electrons than protons. Now, atoms can never form ions by gaining or losing a proton, so that never happens. Atoms don't change the numbers of protons. And if they did, they wouldn't form ions, they would turn into different elements. Remember, because if I have a sodium atom, if I was to take a proton away from a sodium atom, I wouldn't make an ion, I would make an element that has 10 protons, which is neon. All right, so don't change the number of protons, only change the number of electrons. Now, this part here is actually quite difficult, so I would recommend if you haven't quite got the hang of that, you might want to pause, go back and watch the last couple of minutes. All right. However, really what you need to understand is that gaining electrons form negative ions and losing electrons form positive ions. So if you're still not 100% sure about this, we'll get a chance to go over this again next year. But if you can relate gain electron to negative ion, lose electron to positive ion, that's good for now. Okay, and finally, we have molecules. All right, so up until now, we've just been talking about single atoms. single atoms like this. All right. However, most matter is made up of particles that contain more than one type of atom. The simplest type of this kind of particle is known as a molecule. A molecule is two or more atoms bonded together. Hydrogen is an example of a molecule. So, here is a hydrogen atom. And here is another hydrogen atom. And this is a hydrogen molecule. All right, and we call it H2. All right, so molecules are very easy to understand. I know isotopes and ions, they've been quite difficult, so let's finish on a high with something that's quite nice to understand. So this molecule is just two atoms of hydrogen stuck together, and we call it H2. All right, and we can do a few more examples. So water is another example of a molecule. So water is H2O. So we would have an atom of hydrogen, then an atom of oxygen, which I'm going to draw bigger because it is bigger, and then another atom of hydrogen. Okay, and that is a water molecule. And we can, of course, use different ways of depicting this. So this is a water molecule as well. You can see I've got this is my hydrogen atom, oxygen atom. Okay, don't worry too much about the shape at the moment. All right, so that's my water molecule. If I wanted to go back and show you my hydrogen molecule, what would that look like? Well, it would be quite simply just the two hydrogen atoms joined together like that. All right, and finally we have carbon dioxide is another example of a molecule. Carbon dioxide is CO2. Okay, so we have an oxygen atom. We have a carbon atom, which is slightly smaller than the oxygen, but you don't have to worry too much about that. And we have an oxygen atom. All right, so molecules are particles made up of more than one atom bonded together. Okay, so what you need to do now is answer 4 questions, only 4 questions. I know it's a bit of a trick, isn't it? That's what you're thinking. So it's not really 4, there's loads. All right, but these should be quite straightforward for you. So find the element carbon in the periodic table. So carbon is up here. All right, now, how many protons are there in an atom of carbon? Now, what I'm going to tell you here, look, the atomic number, that tells you the number of protons. Okay, so boron, 5 protons. Carbon, 6 protons. Nitrogen, 7 protons. Oxygen, 8 protons. Okay, how many electrons are there in an atom of carbon? So remember, we've done now the number of protons equals the number of electrons. If the number of protons and neutrons in one atom of carbon 12 adds up to 12, how many neutrons are there in an atom of carbon 12? All right, so, excuse me, so we've got 6 protons, okay, tells you the number of protons. But the number of protons plus the number of neutrons is 12. So how many neutrons are there? All right, so that should be fairly straightforward to work out. All right, so that one there is going to be one type of question, and the next, oxygen, do the same thing, but now we're going to ask you about ions, and then I'm going to ask you about, so I think this is quite straightforward, it's in the notes. At the centre of the atom is a nucleus. This is easy, this is easy. That you'll have to think a little bit about, but I think you can do it. And 4, ammonia is a gas at room temperature. All right, and I think there shouldn't be any trouble with those. All right, so that shouldn't take you too long. All right, probably about 20 minutes, 30 minutes max. Okay, if you have any questions, let me know. Otherwise, I'll see you all next week for a little bit of physics.